Hello, everybody. So today we're going to discuss independent and dependent events. At the end of the day, it is expected that you will be able to identify when successive and combined events are independent and when they are not. Also, it is expected that you will be able to understand how to find the theoretical probabilities of combined events. So in the previous topic that we have discussed, we are talking about just one event, like the probability that we will get ahead in a toss of a fair coin, or probability of getting an even number when we throw a dice. Now, we will be talking about two or more events that are in succession, like the probability of you attending maths class and then doing your assignment in maths afterwards. Or it can also be combined events, such as the probability of you attending maths class while eating. So let us consider two normal and biased dice being rolled. Now, does the result for one die affect the result of the other? That is, for example, we were able to roll 3 in our first die. Would it stop us from getting also a 3 on the second dice? No, right? Does the result for one die affect the result of the other? So let me write that. Does the result of one die affect the result of the other? Yes, the answer is no. What you get in one die will not affect the result for the second dice. Therefore, the results for the two dice are said to be independent events. Okay, let me write that. Therefore, the result for the two dice are independent events. So, if the outcome of one event does not affect the outcome of another event, then they are said to be independent events. Now, let us have another situation. For example, we have a raffle wherein we have 3 prizes. Okay, so let me write here 1, 2, 3. And we have 3 winners. Okay, and each winner will choose from one of these 3 prizes. Now, if we have the first winner, then the first winner can choose from the 3 prizes, right? So that the first winner can get the first pack, or the second pack, or the third pack. Okay. Now, for example, the first winner chose the third pack. Then, how many packs will the second winner choose from? Can the second winner can still choose the third pack? No, right? The second winner can therefore choose from the two remaining prizes. Okay. Now, suppose the second winner choose the first pack. So if we now have a third winner, can the third winner still choose the third pack and the first pack? No. The third winner will choose the prize that is left. Okay, so therefore, these events are dependent events because each of the event affects the other. Okay, so that's how we describe dependent events. If the outcome of one event affect the outcome of another event, then they are said to be dependent events. Okay, so let us have this flow chart. Okay, and hopefully this will help you to remember how to identify if events are dependent or independent. So the first question you should ask yourself is it possible for the events to happen in any order? And if your answer is no, then these events are dependent events. Okay? Now, if your answer is yes, then the events, you have to ask yourself, does one event in any way affect the outcome or the odds of the other event? If your answer is no, then these events are independent. Otherwise, they are dependent events. So let us use this flowchart in determining these events, if they are dependent or independent. So number one, tossing a coin, then rolling a die. What do you think? Are they dependent or independent? So let us use our flowchart. Is it possible for the events to happen in any order? Is it possible that we can toss a coin, then roll a die? Or we can do rolling a die first before tossing a coin? Would there be any changes if we change the order of these events? What do you think? Okay. Yes, it's possible for the events to happen in any order. So therefore, we ask the second question. Does one event in any way affect the outcome or the odds of the other event? Will tossing a coin affect whatever the outcomes of rolling a die? No, right? So therefore, they are independent events. Okay, so let us have the second one. Actually, we still have 5 more, but let me check if you could follow the flowchart and decide on your own if the events are dependent or independent. So go to www.bit.ly/ID practice. Okay. So I will give you 5 minutes to answer if the events are dependent or independent. So timer starts now. So, time's up, guys. Now, let us discuss the answers. So, purchasing a car, then purchasing a coat. Are these dependent or independent events? So, is it possible that we purchase a car first, then purchase a coat? And is it also possible that we purchase a coat before purchasing a car? Yes, that's possible, right? Now, will it affect purchasing a car when you purchase a coat first? Or will it affect purchasing a coat when you purchase a car first? It won't, right? It won't affect. So, therefore, they are independent events. Now, how about number 3? Parking, then getting a parking ticket. Is it possible for the events to happen in any order? Is it possible that we get a parking ticket first before we park? No, right? You need to park first before we get a parking ticket. So therefore, they are dependent events. How about number 4? Not paying your power bill on time and having your power cut off. So is it possible for the events to happen in any order? Is it possible that your power will be cut off before you not pay your power bill on time? No, right? It's not possible. Okay? It's not possible that you are paying your bill on time and then your power will be cut off, right? So these are dependent events. How about in number 5? Choosing a card, not replacing it, then choosing another. Okay, so let us imagine this. For example, we have, how many cards do we have in a deck? So we have 52 cards, right? Now, from the 52 cards, we got a king, for example. Now, after getting the king, we did not replace it. So therefore, how many cards were left? There are now only 51 cards. So if we will choose another card, okay, if we will choose another card, is it the same as choosing the first card? Remember, when we choose our first card, our probability here is getting one card out of the 52 cards, right? Now, when we are going to choose another card, the fact that we only have 51 card left, then therefore the probability is going to be now 1 over 51. So therefore, choosing the first card will have an effect on the outcome of choosing the next card. So therefore, they are dependent events. So this is what you should remember. Whenever there are events wherein we get something, like for example, in a bag, there are marbles. When we get one marble and we do not replace it, that is dependent events. Okay, whatever event that we pick one object and we do not replace it, they are always dependent events. Now, let's go to number 6. We are choosing a card and replacing it. So this time, we now replace it. Then choosing another card. So again, we have 52 cards, right? So again, for the first card, for example, we got a king. Now, we replace this time. Okay, after getting the king, we replace it with a king also. So therefore, in choosing the next card, how many cards do we have? Yes, we still have 52 cards because we replaced it, right? So therefore, in choosing the next card, the probability of choosing the next card will still be 1/52, just like the probability that we have in choosing the first card. So therefore, the outcome of the first event does not affect the outcome of the second event. So therefore, they are independent events. So again, whenever you see something like when we pick an object and replace it, okay, then these events are independent. Okay, so I hope you understand the difference between dependent and independent events. Now, let us have an example. A box contains 4 red marbles, 3 green marbles, and 2 blue marbles. 1 marble is removed from the box and then replaced. Okay, so there's a word there that it is replaced. So again, when we see a word that replaced, then what events are we talking about? Then we are talking about independent events. Sorry. Okay, now let's continue with the problem. Another marble is drawn from the box. What is the probability that the first marble is blue and the second marble is green? Okay, so we are talking about how many events? Yeah, so we are talking about 2 events. Our first event is the first marble is blue, while our second event is the second marble is green. Okay. Again, they are independent events because when the first marble is removed from the box, it is replaced. Okay. Now, we can calculate the probability of these combined events using a tree diagram. Okay. So, how many different types of marbles do we have? So we have the red, the green, and the blue marbles, right? So meaning from our bag, if we're going to choose the first marble, we have, it is possible that when we pick a marble from the bag, it is possible that we will be getting a red marble, right? And it is also possible that when we pick a marble from the bag, we might also get a green marble. And it is also possible that when we get a marble from the bag, we will be getting a blue marble. Okay, now let us find from the probability of these different colors, the probability of getting these colors. So what is the probability of getting a red marble? Again, how do we get the probability of an event? That is the number of favorable outcomes all over the total number of possible outcomes. Or in other words, we are talking about the number, since this is red, then we're talking about the number of red marbles over the total number of marbles. So how many red marbles are there? There are 4 red marbles. And the total number of marbles are 4 plus 3 plus 2, right? Which is equal to 4 over 9. So therefore, the probability that we get a red marble is 4 over 9. Now, what is the probability that we get a green marble? So, to get this probability, we need to know the number of, since we're talking about green, we need to know the number of green marbles all over the total number of marbles. So, how many green marbles are there? There are 3 over the total number of marbles is 9. So therefore, the probability of getting a green marble is 3 over 9. Now, what's the probability of getting a blue marble? So again, that is the number of blue marbles all over the total number of marbles. And how many blue marbles are there? There are 2 blue marbles over the total number of marbles is 9. So therefore, the probability that we get a blue marble from the bag is 2 over 9. Now, note that the sum of joined branches, so we have 3 branches, right? And the sum of this joined branches, what is the sum? So we add 4 over 9 plus 3 over 9 plus 2 over 9 is equal to 9 over 9 or equal to 1. So when doing a tree diagram, always remember that the joint branches, the sum of the probability in the joint branches should add up to 1. Now, how many times do we have to choose a marble from the box? Yes, twice, right? So we need to create another branch to our tree. Since this is only the probability of getting the first marble. So let's create another branch. So again, this is our first marble. In getting our first marble, we have a possibility that we will be getting a red, a green, or a blue. Okay. Now, supposing we pick a red marble. Now, for our second marble, what are the different choices or the different possibilities that we could get for our second marble? Yes, we can. It is possible that we will be able to choose a red marble. Yes, because there's still a red marble inside the bag, right? And there is also a possibility that we will be getting a green marble. And there is also a possibility that we will get a blue marble for our second marble. Right. Okay. Now, how about if our first marble is green? Is it possible that we could still choose a red marble for our second marble? Yes. And there is also a possibility that we can pick a green marble. And there is also a possibility that we could pick a blue marble. Now, if our first marble is blue, what is the color possibility for the color of our second marble? Yes, it is also possible that our second marble would be red. It can also be green if our first marble is blue. And it can also be blue. Okay, now let us now assign the probabilities. Again, what's the probability that we get a red marble for the first marble? So that is how many red marbles do we have? 4 out of 9 marbles. Probability of getting a green marble, that is 3 over 9 because we have 3 green marbles. And probability that we get a blue, that is 2 because we have 2 blue marbles over 9. Okay. Now, how about here? How many marbles do we have when we are going to pick the second marble? Is it going to be the same, 9? Or it's going to be less than 9? Because we already picked the first marble. Yes, it will all still be 9 because take note, when we pick our first marble, we replaced it. Yes. So therefore, even though our first marble is red, for our second marble, it is also be possible that we could choose red, and that would still be 4 red marbles because we replace it when we pick a red marble for the first time. So therefore, the probability of getting a red marble for the second time is still going to be 4 over 9. And in picking the second marble, how many green marbles are there? Yes, there will still be 3, and there will be still 9 marbles inside the bag because we replaced it, right? Now, in picking the blue, yes, there's still 2 blue marbles inside the bag. So therefore, the probability of picking a blue is 2/9. Now, if our first marble is green, then the probability of getting our second marble would still be red, still be 4/9. Okay. Probability of getting a green would still be 3/9. And probability of getting a blue would still be 2/9. And if our first marble is blue, the probability that our second marble is red would still be 4/9. Probability of picking a green for the second marble would still be 3/9. And probability of picking a blue for the second marble would be 2/9. Okay. Now, what are the outcomes? Okay. For our outcomes, so we have here, the first marble is red, and the second marble is red. So that is our first possible outcome. The second possible outcome is the first marble is red and the second marble is green. The third possible outcome is our first marble is red while the second marble is blue. The fourth possible outcome is our first marble is green and the second marble is red. The fifth possible outcome is our first marble is green and the second marble is green. And the sixth possible outcome is our first marble is green and the second marble is blue. The seventh possible outcome is our first marble is blue and the second marble is red. While the eighth possible outcome is our first marble is blue and the second marble is green. And the last possible outcome is our first marble is blue and the second marble is also blue. Okay, now to work out the probability of a particular, so how many outcomes do we have? We have a total of 9 outcomes. So to work out the probability of a particular outcome, the probabilities of those branches are multiplied together. Okay, so in finding the probability that our first marble is red and our second marble is red, is going to be 4/9 times 4/9. Or that will be 16/81. And the probability that our first marble is red and the second marble is green would be 4/9 times 3/9, or that would be 12/81. And the probability of getting the first marble as red and the second marble as blue is 4/9 times 2/9 is equal to 8 by 81. Okay, and the probability that the first marble is green and the second marble is red would be 3 by 9 times 4 by 9. Okay, 3 by 9 times 4 by 9, or that would be 12 by 81. And probability that the first marble is green and the second marble is green is 3 by 9 times 3 by 9, or that would be 9 over 81. And the probability that our first marble is green and the second marble is blue, that would be 3 by 9 times 2 by 9, or that would be 6 by 81. And probability that the first marble is blue and the second marble is red would be 2 by 9 times 4 by 9, or that would be 8 by 81. And probability that the first marble is blue and the second marble is green would be 2 by 9 times 3 by 9, or that would be 6 by 81. And last but not the least, the probability that the first marble is blue and the second marble is blue, that would be 2 by 9 times 2 by 9 is equal to 4 by 81. Now, if you will notice, the sum of the probabilities of all the 9 outcomes would be still equal to 1. Okay, the sum of these 9 outcomes, would be equal to 1. Now, let us answer the question, what is the probability that the first marble is blue and the second marble is green? Where is that from our outcomes? Again, the first marble is blue and the second marble is green. So, where is it? Yes, so this is it. This is the outcome, the probability that we are looking for. The probability of the first marble is blue and the second marble is green. So that would be 6 over 81, or that would be equal to 2 by 27. So that is answer to the question. Okay, now let us have another example. Oh, what is the probability that the marbles are of the same color? So let us go back to our tree diagram. So when we are talking about the same color, okay, so let's write that. Probability that the marbles are of the same color. So in other words, we are looking for the first marble is red and the second marble is red, plus the probability that the first marble is green. So if the first marble is green, then the second marble should also be green, plus the probability that the first marble is blue. And if the first marble is blue, since the same color, then the second marble should also be blue. So let's go back to our tree diagram. So we have 4 over 9, that's red. And the second marble should also be red. So we will multiply 4 over 9 to 4 over 9. While the probability that the first marble is green is 3 over 9. And the probability that the second marble is green is 3 over 9. So let us multiply that. Now, the probability that the first marble is blue is 2 over 9. And the second marble is blue is also 2 over 9. So let us multiply them. So therefore, the probability that the marbles are of the same color would be 16 by 81 plus 9 by 81 plus 4 by 81. Or that would be, what is 16 plus 9 plus 4? So that would be 29 by 81. Okay, now let us have another example. Okay, we still have a box that contains 4 red marbles, 3 green marbles, and 2 blue marbles. Now, 1 marble is removed from the box. And now, this time, it is not replaced. Okay, then we will still get another marble from the box. So, and we are still going to find the probability that the first marble is blue and the second marble is green. Now, when you see that something that when we got an object from the box and it is not replaced, what events are we talking about? Are they dependent or independent events? Okay, they are, as we have discussed earlier, they are dependent events. Now, let us show that in our tree diagram. So, again, we have a box wherein we have a red marble, we have green marbles, and we have blue marbles. Okay, so this is our first marble. And then we are going to get second marble, right? Okay. And still, when our first marble is red, it is also possible to get a red for our second marble. And it's also possible that we will be getting a green for our second marble. And it's also possible that we will be getting a blue for our second marble. And it's also possible that we will get a red for our second marble. If our first marble is green, it's also possible that our second marble would also be green. Why? Because there are 3 green marbles in the bag. And it's also possible that we're getting a blue marble. Now, if our first marble is blue, it's still possible that we can get a red marble for the second one, a green marble for our second marble. And if our first marble is blue, it's still possible that our second marble is blue since there are 2 blue marbles. Okay. So, let us analyze our probabilities. The probability that our first marble is red is, again, there are 4 red marbles. And we have 9 marbles, okay, when we pick our first marble. Now, it is said that after picking the first marble, it is not replaced. So if it is not replaced, how many marble will there be when we pick the second marble? Okay, again, we have 9 marbles at the beginning from our box. Okay, now in this situation, our first marble is red. So we were able to get 1 red from the box, 1 red marble. So if there are 9 marbles at the beginning and we remove 1 red marble from the box, how many marbles are going to be there when we choose the second one? Yes, so for the second marble, okay, our total number of marbles will now be 9 minus 1, right? Because we already picked 1 marble from the first one. Okay, so that would be, we are now reduced to a total of 8 marbles. Okay, now, what is the probability that our second marble is red? Again, that would be the number of red marbles over the total number of marbles, right? So if our first marble is red, we already picked a red marble. So what is the probability for the second marble to be red? We already removed 1 red. So therefore, our probability is going to be 4 minus 1, right? Because our first marble is red all over the total number of marbles, which is now 8. Okay, and that will be 3 over 8. So therefore, the probability here is 3 over 8. Now, what's the probability that the second marble is green? So the probability that the second marble is green is the number of green marbles over the total number of marbles, right? And how many green marbles will there be if our first marble is red? Will it be 3 minus 1? No, because our first marble is red, not green. So therefore, the number of green marbles inside the bag will still be 3. And the total number of marbles is still 8 because we already removed 1 marble from the first pick. Okay, so therefore, the probability here is 3 by 8. Now, for the blue marble, what is the probability? How many blue marbles will there be inside the box if our first marble is red? Yes, there will still be 2 blue marbles, okay, but that will be over 8. Now, let us talk about the green marble to be the first marble. In choosing the green marble as our first marble, how many green marbles will there be? There will be 3, right? There will be 3 green marbles out of how many marbles? That would be 9, okay? Now, if our first marble is green, what's the probability that our second marble is red? Since the first marble is green, then therefore the number of red marbles inside the box will still be 4, right? So that will be 4. But this time, since we remove 1 marble from the box, then therefore the total number of marbles inside the box will now be 8. Okay? Because we did not replace the first marble. Now, if our first marble is green, the probability of getting another green marble, okay, so how many green marbles will there be if our first marble is green? Yes, so there be only 2 green marbles left inside the box because our first marble is green. So this is 2 over 8. Now, how many blue marbles will there be if our first marble is green? Yes, there will still be 2 out of 8. Okay, now let's go here on the possibility that our first marble is blue. Okay, so the possibility that we will get a blue marble for the first marble would be, how many blue marbles are there? 2 over out of 9 marbles. Now let's go here. How many red marbles will there be? Still, there will be 4 because our first marble is blue, and over 8. How many green marbles? Yes, there will still be 3 over 8. And how many blue marbles would there be if our first marble is blue? Okay, since we already removed 1 blue marble from the first pick, then our blue marble this time for the second, in picking the second marble, we now only have 1 blue marble over 8. And the probability of the outcomes, okay, so we will have probability that the first marble is red and the second marble is red. Again, we will multiply them. So that's 4 over 9 times 3 over 8. Okay. Probability that the first marble is red and the second marble is green would be 4 over 9 times 3 by 8. And this is the probability that the first marble is red and the second marble is blue is 4 by 9 times 2 by 8. And the probability, this is the outcome, that the first marble is green and the second marble is 8 is 3 by 9 times 4 by 8. This one, probability that the first marble is green and the second marble is green would be 3 by 9 times 2 by 8. And here, probability that the first marble is green and the second marble is blue is 3 by 9 times 2 by 8. And here, the probability that the first marble is blue and the second marble is red is 2 by 9 times 4 by 8. And here, probability that the first marble is blue and the second marble is green is 2 by 9 times 3 by 8. And here, the probability that the first marble is blue and the second marble is blue is 2 by 9 times 1 by 8. Now, again, what probability are we looking for? We are looking for the probability that the first marble is blue and the second marble is green. And where is that? Okay, so this is it. This is the probability that we are looking for. So that would be 2 times 3. So that will be 6 over 72. Okay, or that is equal to 1 by 12. Okay, so if you will get the product of each of the outcomes and add the probability of the 9 outcomes, the sum would still be equal to 1. Okay, now, what is the probability that the marbles are of the same color? Okay, again, we have 4 red marbles, right? Then we have 3 green marbles. Then we have 2 blue marbles. So the probability that they are of the same color, again, this is probability that the first marble is red, then the second marble should also be red, plus the probability that the first marble is green, and the second marble should also be green, plus the probability that the first marble is blue and the second marble is also blue. So take note, this is without replacement. Okay. So probability that the first marble is red would be 4 over 9 times the probability that it is red. Now, since this is without replacement, so the probability of choosing another red, how many red marbles will be left for us for the second one? If our first marble is red, then we're going to have only 3 marbles in choosing the second one. Out of the 9 marbles will now be reduced to 8. Plus, probability that our first marble is green is 3 by 9. Now, since we already removed 1 green from the first pick, then for the second pick, we will now be left with only 2 green marbles out of only 8 marbles. Plus, probability of getting a blue is 2 by 9. Okay, let me erase that. That is 2 by 9. And the probability that we will pick another blue is, since our first marble is blue, so we now only have 1 blue marble left out of 8 marbles. So that will be 12 over 72 plus 6 over 72 plus 2 over 72. Or that would be equal to 12 plus 6 plus 2 is 20 over 72. Okay, and reduce that. That would be, we divide this by, let's try 2. So that would be 10 over 36. Okay, which is still divisible by 2. So that would be 5 over 18. So that is our answer. You might want to compare this with our first example earlier, wherein it is with replacement. And you will notice that we are going to get different probability. Okay, so that is the difference when we have independent events and here dependent events. Okay, Now, here, let's have another example. You randomly choose a flower from the vase to take home. Your friend randomly chooses another flower from the vase to take home. What is the probability that you choose a purple flower and your friend chooses a yellow flower? Okay. Now, what kind of events are we talking about here? Okay. It is not said that we replace the flowers, right? So they are dependent events. Okay. So we are talking about two events. Okay. First one is the first flower is purple. Okay. So what is the probability that our first flower is purple? How many purple flowers are there? There are 7, right? Out of how many flowers? So that is 7 plus 9 plus 12. Which is going to be equal to 7 over, what is 7 plus 9 plus 12? So that would be equal to 28. Now, the second event is the second flower, which is the flower that your friend got, is yellow. Okay. Now, how many yellow flowers are there? So we now have 9. Okay. Over how many flowers will there be when your friend chooses the second flower? How many purple flowers are there? Originally, there are 7, but this time, since you already picked the purple flower, it's now going to be 6 plus, yes, the yellow flower will still be 9, and the pink flowers will still be 12. So therefore, in picking the yellow flower, that would be 9 over 27. So therefore, the probability of picking purple, then yellow, is we are going to multiply them. So that would be 7 over 28 times 9 by 27, or that be equal to 63 over 756, or that be equal to 7 over 84. Okay. Now, I want you to answer this. Okay, so this is number 1, number 2, number 3, and number 4. Okay, so I'm going to post this in our Google Classroom. So do this as your seat work for today. Okay, so I hope you were able to understand our topic. Okay, and I hope that you will be able to answer correctly these items. Okay, that will be all. I will see you tomorrow. Bye-bye.